Hello, everyone, and thanks for taking the time to be with us today. And today we are having a new webinar prepared for you in which we're going to talk about data preparation and cleaning. For everyone who's new to this webinar series, my name is Jan Willem Middelberg, and I'm the author of the Enterprise Big Data Framework. And in the next 45 minutes, I'm going to give you an in-depth lecture around how you could use some basic and advanced data cleaning techniques in order to deal with data sets. If you've had the opportunity to already participate in some of our previous sessions, note that we will first cover a little bit of the theory around it, but that the whole purpose of this webinar series is to also provide a practical aspect. And with this practical aspect, we're going to look at a lab so that you can hands-on play with the data sets that we're going to be providing. So you get to roll up your sleeves and also practice with some of these key concepts in real life practice. So what have we prepared for today? Let's have a quick look at our agenda for today. First and foremost, I'm going to place this webinar into the whole series and the context of the Enterprise Big Data Framework, which is hosting this series of webinars. And I'm going to be painting a bit of the bigger picture around why this is important. Then secondly, we're going to look at some basic data inspection techniques. And this is generally a pre-processing step that you would always need to do before you start analyzing and cleaning any kind of data set. And then as the third main part, we're going to look at how this will all work in practice. So I'm going to give you a quick demonstration of how data inspection and data cleaning works in a real life environment. And we're going to be doing that by looking at one of the labs that I've prepared in Python. In this last section, you can just follow along and I will share the links in the data set with you. So after this overview, you can keep practicing with the data yourself. Throughout the whole webinar, I always encourage everyone to interactively participate. So if you look at the left of your screen, you will see a chat and Q&A function. If you would like to get a quick answer from my colleagues or from somebody who's listening as well, please use the chat function. If you have questions which you'd like me to answer at the end of the session today, then please use the Q&A button. In the Q&A functionality, people can upvote questions. So at the end of the session, I will look at the most important questions and we will moderate them together. So try to keep this as interactive as possible. Good, let's get started with a bit of background around the program and what you can expect from the Enterprise Big Data Framework. For those of you who are new to it, the Enterprise Big Data Framework Alliance is an independent body of knowledge for the development and advancements of big data practices. We're trying to inspire, promote, and develop excellence in big data best practices by increasing standardization, looking at best practices and best ways to do things. And all of that is done from a vendor independent point of view. The materials that I'm going to cover today are largely based on the second level of the Enterprise Big Data Certification Scheme, which you can see on the right-hand side of this slide. More specifically, some of the labs that we're going to be covering today are part of the Enterprise Big Data Analyst course. And in this course, you will learn how to analyze large data sets as well as build algorithms in order to explore that further. After this program, I highly encourage you to go to the website and download the entire syllabus or read the books. At the end of the session, I will give you some guidance around how you could download the original textbook, which is also a part of this program. Note that the whole program itself is based on the Enterprise Big Data Framework, which is the figure that you see on the right bottom corner. And the Enterprise Big Data Framework consists of 6 main capabilities that every organization needs in order to become more data-driven. The way that we're going to look at this today is that we are going to specifically focus around the algorithms section of the Enterprise Big Data Framework. And specifically, we will zoom into data cleaning operations, which is a very essential part of developing algorithms. You can have the best algorithm in the world, but if the data that you feed into the algorithm is incomplete, inconsistent, or still contains mistakes or missing values, then in most cases that will impact the results dramatically. So it's very, very important that before you start crunching the actual numbers, that you are very precise and consistent that this is actually data that you can trust and that it's properly cleaned. And that's going to be the main purpose of the quick session that we will discuss today. Now, let's have a quick look at what do we mean with this. And data cleaning, as you might have seen in the description of the session today, is a fundamental step in what we refer to as data preparation. With data preparation, we mean that we make sure that a data set is ready to be analyzed or to be queried by a specific algorithm. And in practice, that means that we would need to review the data set very thoroughly and have all kinds of mitigation plans and strategies to deal with duplicate, erroneous, or sometimes even just plain missing data. It's very unusual or very unlikely in practice, and I think that most of you who are listening in live today can validate this, that you will receive a clean data set to start with. Most data sets that you will analyze, especially when it comes to enterprise data, have been built up over time, in which fields have been changed, in which descriptions or form fields might have been adjusted. And that typically results into quite some duplicate or messy data. And if you think that you are alone in that area, I can assure you that's definitely not the case. On the right-hand side of this slide, you can see a very famous article from the New York Times that mentioned that the janitor work of data science is one of the most significant hurdles to achieving and obtaining good insights. Other research shows that data science teams are frequently busy from around 50 to 80% of their time on data cleaning and data wrangling activities, which has very famously labeled this step of data science as the janitor's job of data science. In real life, and I can assure you this from practice, is that you will spend a very significant amount of time looking at data sets so that you can validate and clean them before you can actually run the algorithm. In my personal experience, this requires the majority of time, because as soon as your data set is ready to be analyzed, then it's just running the specific algorithm. Within the domain of data preparation, there are two very significant terms that are both part of the same approach. And those are referred to as data cleaning and data wrangling. Although many people and organizations use these terms interchangeably, there is actually quite a significant difference. And in this section, we will follow the very popular tidy data approach by the famous data scientist Hadley Wickham, who pioneered this topic. And I personally like this approach a lot because it gives you a clear separation between activities that are referred to as the cleaning steps. And with cleaning, we specifically look at the process of detecting and correcting corrupt or inaccurate records from data sets. So in most cases, what that will result into is that we will need to replace, modify, or delete the dirty sets or the dirty parts of your data set. In almost all cases, that means that you will need to alter existing records, and that the records that you will feed into the ultimate model are going to be different than from what you have before the data cleaning starts. The other step of data preparation is referred to as data wrangling. And data wrangling is the process of transforming and mapping data from the raw format with which you typically begin towards a format that is readable by the algorithm, or in many cases, which has been optimized for speed and the specific input requirements of the algorithm. So for those of you who are familiar, if you think about aspects like hot encoding for categorical data, then data wrangling would separate these categorical values into numeric ones so that they can be read by algorithms. And that's just a very simple example of what data wrangling does. Now, why is it important to differentiate between these two steps? Well, the data cleaning in itself is going to utilize different techniques than what you typically see with data wrangling. I always think it's very important that you have a very clear understanding of what those differences are, because if you ever need to build a machine learning pipeline, then generally it's recommended to first do the data cleaning steps before doing the data wrangling. And that has a lot of very practical implications. And therefore, what I typically do when building these machine learning pipelines is to separate these two different activities and not just include them as a single step. So hope that you will use that after this as well. Now, this separation has been based on the term tidy data, which was first used in the 2013, now quite famous white paper in the Journal of Statistical Software, which was written by Hadley Wickham, whom I just already referred to. This approach makes it easier and, in my opinion, much more comprehensive to start thinking about the way that data is structured, and especially around the way that it's going to be built up in terms of its semantics. Generally speaking, and I'm deliberately oversimplifying things a little bit right now, we can consider a data set as clean or tidy or properly structured, regardless of how you would like to call it, if it follows three very important principles. And the first principle is that every variable forms a separate column. This is going to ensure that you can review columns independently, and that all the values or observations are going to be different based on the column names. Secondly, we want to make sure that every observation is structured into a particular row. So the larger your data set becomes, it will grow downwards, and we will have very long form data sets for observations. Later, in later webinars, or if we have time at a later moment in time, then I'm also going to show you that this has implications for your database design and database structures. Because if you don't follow this principle and you have very wide database columns, then that might lead to restrictions or specific performance problems from a database perspective. So the second part is not just there because it's very useful, which it obviously is, but also because it will help from a performance perspective. And third, and very importantly, is that we would like to have each type of observational unit as a separate table. So for those of you who are a little bit familiar with database design, this means basically a different form in a table, or a specific, if you would like to draw the analogy to Excel, this would be a different Excel sheet within the Excel workbook. So if you follow these three principles, you will always have a tidy data set. And more importantly, you will also have a good structure for ultimately your database design. So the different concepts that we're going to talk about in this segment are going to be based upon this specific approach. After the webinar, I will post the link towards the white paper in our description. But if you just Google tidy data, I'm quite sure you will be able to find the white paper quite quickly. Good. So what does that mean in practice? So I'm going to dive a little bit deeper right now and look at the different techniques that you could use for data cleaning and data wrangling. I'm going to separate that into a number of the most common techniques, which are divided over these two main topics. So we will continue the structure that we have and separate it into these two different modules. On the data cleaning side, what we will discuss in this webinar is selection, filtering, arranging, renaming, mutation, and summarization. And on the data wrangling side, we'll talk about gather, spread, as well as how to deal with missing data. And specifically, we're going to look at drops, replaces, and filling data sets. So that's going to be the main topic of the section today. And after this, I will also show you how you could do this in a real life environment. Now, it's always best to illustrate things with some examples. And for the section today, I've chosen an open data set with values that depict the economic freedom of the world. I know that we have many people listening from various countries and various places from all across the globe. So I thought this would be a useful data set because there is information around every country. And regardless of where you live, there will be something that will relate to you. The report that I've chosen is online available, but I will also give you a link towards the data set. And the report that we're going to look at is the 2018 version, which consists of 36 different columns or variables and around a small data set of around 3,700 different rows. I've chosen not too large a data set for today because I'm going to do a live demo, and we want to make sure that we don't need minutes to do actual calculations or actual operations. So you'll be able to follow it live. Technically speaking, you could use the same approaches to every data set and every data size. So that's going to the structuring part is not going to matter for the amount of data that you're going to be looking at. What does the economic freedom of the world data set do? It's going to look at a summary term which is considered economic freedom by looking at government, legal structures, access to money, freedom of trade, and regulation for credit, labor, and businesses. You can review the different columns and scoring criteria in the report itself. But for the sake of the example today, I'm going to just show you how you could use the techniques, but you could equally apply this on any other kind of data set. Now, let's get started with reviewing some of the best practices. And I think that it's very important that if you progress in your career in data science, is that you get familiar into what I like to refer to as good habits. And what I mean with good habits is a structured approach that you will always take regardless of what your data set at hand is, and that you will be comfortable and be using these same practices over and over again. And in terms of the pre-processing start or data preparation, as we've just referred to it, is that it should be a three-step process. It starts with a data inspection stage in which we review the structure and the data sets that we have under consideration. Then we move towards data cleaning, in which we will tidy up our data based on any kind of missing, erroneous, or duplicate information. And last but not least, that's when we're moving towards the data wrangling stage. And as I just mentioned, with data wrangling, we're specifically looking at the way that you can change your data set to make it fit for the algorithm that you're going to be utilizing. Now, I'm going to get started very quickly with some data inspection steps. And in these data inspection steps, it's best practice to look at three main aspects, which is to start with the review of the structure of the data set, then to look at the top and the bottom of the data set, and then finally to look at some of the key summary statistics. Let's review that a little bit more in detail. What I will show you on the next few slides is how you can apply this and what are some of the quick commands that you could utilize in the two main languages, obviously R and Python, as we've been doing in the other webinars as well. And we're going to look at, first and foremost, the structure. Now, in one of the previous webinars, I went into a lot of detail around why data structures are important and the way in which the structure of your data is going to have a significant impact on the way that your algorithm will work or won't work in most cases. And just as a quick review, and I can refer to you to the previous webinar in case you missed this part, is that data, it comes in a number of primitive data types, which are the integers, floats, booleans, and strings. And in the first step of doing anything with a data set, you first would like to explore what the underlying data structures actually are. The way to do that is listed here on the screen. The example that we're going to be using and showcasing today is going to be listed in Python. So we are going to be using the dtypes command in order to review the structure of the data set. So here's a quick example. Here we will read in the data set itself, and here we're going to look immediately at the structure of the data itself. So from this observation, you can very clearly and very quickly see that we will have integer values, which is obviously how the years are displayed. We will have factorials or categorical values, as we like to refer to them in Python. We will have some numeric data as well, as we can see, for instance, in the economic freedom score that is listed around, etc., etc. So this is going to give you right away a very good information around what is the type of data that we are having under consideration. Then as a second step, we're going to be looking at structuring this specific result. And as you will know, or most of you will know, it's generally best practice to structure this into a data frame. And what we would like to do is make sure that we align to those practices that we just mentioned. So every row, a separate observation, and every variable into a different column. If we review the results that we have done so far, we saw, we can, for instance, see on the original data sets that there's 36 different columns for different years. So that obviously means that it will not follow the tidy data structure. And that's exactly why I've chosen this data set, because there is quite a lot of work that needs to be done in order to actually tie it up. Good, let's look at this from a specific example. In the second step of data inspection, what we typically like to do is to have a glimpse of the data. And especially if you have larger data sets, it's going to be impossible to review everything. So it would be useful to at least review the first few rows and the bottom few rows. And this is generally what we refer to as looking at the heads, which is typically the first 5 observations, and then the tail, which is typically the last few observations. Why do we do this? Well, this generally gives you quite quickly an overview of the way that your data is going to be structured, and more importantly, if there are any missing values. It's always important to look both at the top as well as the bottom. And the reason for that is, as I can show you right here on the slide. If you would look at the first few rows immediately, it might well look as if there is nothing wrong or there's nothing missing within the data set. All the values are there, everything is measurable, so it looks like there's no issues with this data set at all. However, if we review the bottom of the data set, then you see that there is more values missing than there are present. And if you zoom in a little bit closer, you can see that this obviously has to do with the data collection process. And obviously in 1970, there was less data measurements available than in the most recent measurement, which was in 2016. So looking at the top and the bottom of the data set is generally a good idea. It's considered best practice. So I always encourage everyone to just make this part of your operating procedures. And even if you already think that you know what the data set looks like, it's good to run it so that you can see it with your own eyes. Good. And then last but not least, it's generally a good idea to review the summary statistics. With summary statistics, we mean the statistics that actively describe and summarize a data set. So there are multiple different ways to do this. Both R and Excel have built-in functions to do this, not just for one column, but for all the different columns that exist. And within R, it's typically referred to as the summary command, whereas in Python, we use the describe function to actually do this. And that will give us right away an overview of exactly what is the data telling us. And it's quite interesting if you do this, because one of the main columns that we're going to be interested in this data set is the economic freedom. So you will see that all values will range from a 1.97 towards a 9.19, with a mean of around a 6.5 and a relatively small standard deviation because the first quarter is at 5.8 and the third quarter at 7.3. So you will see that around 50% of observations is between that 5.8 and that 7.3. So a lot of countries are close together, with some more outlier countries more towards the lower end of the spectrum. And that's why this immediately tells you a lot of information around what is it that we're actually looking at. We can also see from this summary command that the oldest data was collected in 1970 and the latest data set collection is dating back towards 2016. So these are, I would say, essential steps in data inspection. So before you even start cleaning, you would like to have a sound overview of what is it exactly that we're looking at. So now that we have that covered, let's move towards our second and main topic for today, and that has everything to do with data cleaning. Just to kind of give you the formal definition, with data cleaning, we mean a process. It's a process of detecting and correcting corrupt or inaccurate records. So it's not a big surprise to see that in a lot of data stores these days, this can be done in an automated fashion because it's actually process automation. We can clean interactively, so we can do it on a case-by-case basis, but in larger organizations, there's obviously going to be a process, automated process for this in place, so that this is not all needed to be done in a manual way. The whole purpose of data cleaning is that a data set after the cleaning operation is consistent with other or similar data sets in the system, and that we don't make decisions based on the wrong information, because that's ultimately the primary reason why we're doing all of this. Now, within the domain of data cleaning, we're going to look at 6 different operations, which are select, filtering, arrange, rename, mutate, and summarize. And I'm going to be going through these relatively quickly, so just to kind of give you an idea of what it is and what it's doing. And then afterwards, you will get to roll up your own sleeves and start looking at these data sets by yourself. Now let's start with selecting, which is one of the most straightforward operations. With selecting, we generally mean keep the columns that we're interested in. In some methods, it's also referred to as subsetting. And basically it means we will only continue with a subset of our original data. There's all kinds of reasons why you might want to do this, but obviously one of them is to reduce your data set and only continue with the values or the columns that will actually provide you with real information or information upon which you can make more actionable decisions. In later webinars and later segments, I will also show you how you can apply specific algorithms to determine which columns you would need to subset, specifically principal component analysis. And not every column in a data set is equal in importance. So there are techniques to not just do this from intuition point of view, but to also do this based on a prediction around what are the most relevant columns to keep. So that's the selection process. The opposite of that is obviously filtering. Filtering means that we will continue with a subset, but instead of rows, we will subset or instead of columns, instead we will subset in terms of rows. On the right-hand side, you can see quite a good visualization where we will see 4 rows initially, and then that translates into 2 rows on the right-hand side. Filtering is done to filter specifically on conditions or to get rid of results that contain missing or erroneous values. We're going to talk about dropping in a second, but that's basically a form of filtering. Good. I think most of you will be familiar with selection and filtering because they are 2 of the most common approaches that we see in data cleaning. In arranging, it becomes a little bit more interesting. Arranging your data or sorting your data is the process to put your data set in a particular order. And in many cases, there is going to be some impact, especially if you arrange your data in a particular way. Again, later we're going to talk about how do we deal with missing values, and note that in those cases, the ordering or the sorting part in which you keep and collect your data is going to be of tremendous importance. And that's why this is relevant. Well, I'm quite sure that most of you will have done this in one way or another in Excel sheets or in other databases. But basically, there are all kinds of different sorting algorithms. The most common ones is obviously by size or by alphabet, and this is how we can structure our data sufficiently. Good, then let's move towards the rename operation, and with renaming we will look at renaming column variables. In most data sets that you will encounter in practice, you will see weird descriptions of columns. You might see inconsistencies between the different column names. And you will have different ways in which, for instance, column names have something which is non-descriptive of what is actually in the column itself. So it's generally good practice to standardize this. You can use different kinds of formats. What you will see in the example here on the slide is how we're renaming the word book value to book value, but then without a space, so that the variable names can be processed in a similar way. And it's relatively simple, again, to do this, but very important from a cleaning perspective. Good. Then we get towards the 2 most advanced parts. Mutation means adding new columns to your data. If it's new columns that have data that is completely different, you could make a case that this is already moving towards data wrangling. So a very common approach is, for instance, to change something from or change the metrics that you're looking at. So a common example that you see here on the slide is changing things from degrees in Celsius to degrees in Fahrenheit. You could do that very easily by adding a new column with the new data. It makes sure that you don't overwrite your existing data, so you can always make the comparison. And in mutation, we're adding a data column, typically as a new format that we're interested in. And then last but not least, especially on the cleaning part, we have summarization. And with summarization, we are looking at giving critical information around the data itself. It's very similar towards pivot tables and Excel sheets, for those of you who are familiar with that. And it does not necessarily, is not so much as a cleaning technique per se, because it does not alter any of the underlying records, but it is frequently used within the cleaning operations itself, and that's why it's been included here as part of the discussion. So those are the 6 most common data cleaning techniques. I will showcase you in a second how you can actually do this in practice. But before we move there, I would like to take a quick moment to see if there are any questions so far. Let me open up the part. Let me go to the Q&A. In the meantime, if you have any questions around this, or you would like us to discuss something in more detail, then by all means, please do so. I see there is not anything urgent at the moment. So if that's the case, I'm going to switch screens right now, and I will bring you towards the lab. And let me share that with you in a second. But before I do that, I'm going to give you the link towards the lab so that you can follow real time with me and be able to follow along in the lab itself. So give me a quick moment to share this with you. So here's the link. I'm going to put it into the chat right now. So here is the link. It should be open. If you make any changes while following along, then please make a copy. Otherwise, if you refresh, everything is going to be deleted. Good. So this is the link to the lab. Please let me know in the chat if you can access it and are able to follow along. Good. In that case, let me share the screen, and we're gonna look at the lab itself. Good. I see a lot of thumbs going up, so that means that I'm hoping it should be clear for everyone. Good. So as you might have seen in some of our previous webinars, we prepare labs because I always think it's important that you not just know from a theoretic perspective how things work, but how does this actually work in practice. And in this lab, we're going to be reviewing the data set that I just mentioned and look at some important data cleaning techniques. So the first thing that you would need to do in this lab is import the data sets. So I've made a link for you available in the lab itself, and that will bring you towards a folder in which the data is structured, which is what you can see in this next tab. You can very easily click on the button download right here, and that's when you will have it locally on your machine. So the first thing that we would need to do is make sure that we have access to the data set itself. And the way to do that in Colab is to go to the folder right over here. And this is where we can start uploading the data. Since I've just been giving the presentation, it's still connecting to the processor in the backend. So give it a quick sample to do that. And I can see that we're already live. So let me just very quickly upload this. And if you rename your file, then you would also need to rename it, obviously, in the code. But as soon as it's uploaded, I can see it's ready right now. I can start reading the data set into my environment. And as you can see by the check mark, that has all been executed already. And it's all there and ready to use. Now, the first few steps that I'm going to run through with you is the data inspection steps. And then after that, we will look at the data cleaning steps. So remember from the theory and the slides that I just showed you is that there are 3 common inspection steps. The first thing that we like to do is take a look at the structure of the data. So I showed you the D types earlier. You could also very simply use the info command, which is similar in nature. What this immediately will tell you is that we will have, in this case, 36 different columns, of which the majority are floats. We will have integers for the years, and then objects, or in other words, strings for the ISO codes and the countries, which makes a lot of sense because the countries are obviously spelled into names. Good, that's the first step. Then the second step that I showed you in the slides is that we are going to have a look at the header and also at the tail or the bottom few rows of the data set. So first we can do the header, and here we will look at the first 5 rows of the data set. And as you can see right here, if I scroll from left to right, it looks like all of our values are present. But again, if we look at the bottom of the data set, you will see that there's actually a lot of missing values, which are indicated by not a number. So from these 2 commands, you can immediately see what kind of data you have. And it's very likely in this case that the more recent observations have more data than older research. And that's exactly why we're doing this particular step. Then last but not least, we would like to summarize, and this is where we could use the describe function. So for every column that it has, it's going to review the different summary statistics. And as we've seen before, there are different ways in which this is going to be structured. The most important column in this case is the economic freedom, because that's the end result that we're most interested in. And here we can see that on average, it's around a 6.5, which is corresponding to what I showed you in the slides. Good, so this is our step 1. And you will see that in almost all of the labs that I've ever written and provided in these courses, I generally make sure that these steps are always followed by everyone. And it's generally good to do this because you can spend a lot of time at later stages figuring out why your algorithm is not working. Whereas in many cases, you will see that, for instance, you overlooked a specific data type, or you would need to do a type conversion. Many things, there can be many reasons why it won't work immediately, but following this best practice 3-step process will help you overcome a lot of those issues. Good, let's then move towards data cleaning. So I know there's a lot of information in this segment, so I'll just showcase you some of the key highlights. Note that everyone will have access to this lab, so you can keep practicing with this yourself. I'll show you some of the most important and basic things. So the first thing that we're going to talk about is subsetting, or keeping specific columns in your data frame. Now, there are different ways to do this, but what I typically like to do for consistency is first to come up with a column vector of the columns that we would like to keep. You can obviously combine these 2 commands, which I'm fully aware of, but for the sake of the example today, and also in case you might want to change this in the future very quickly, you could first define a column vector and then subset against that column vector. So in this case, we're interested in keeping the columns years, ISO code, the country name, and the economic freedom. So we're basically getting rid of everything else, and we're just interested in keeping the final score. So 4 columns. If we do this, then we will subset for those 4 columns alone, and we will change that towards a data selected new data frame, which again is going to be indexed and 0-based indexed. So we do this, and I'll run it again. Here you can see that it still remains the same, and we will see exactly what will be the economic freedom for each country in each particular year. Good, so that's the first part. Then let's move towards filtering. And in filtering, we keep rows most commonly around a specific condition. And the condition that we're going to look at today is a specific year. So a way to create a filter is to just specify the condition within the subset. So here, what we're doing is we're subsetting for the year column. And basically what this tells us is that we will only keep the rows for which the column year states exactly 2016. You can very easily change this to another year or make it greater or less than that particular year. But for the sake of the example, I'll just show you how this one works. So if we were to scroll towards the year part, which is the first column, you can see that the first few rows are all 2016 and the end years as well. So it means that in total we have 162 observations, each corresponding to a different country, 4 observations in the year 2016. So that's the subsetting that we're doing right now. Now, the next key operation that we can look at is then arranging. And remember that we can arrange in any way we like. We can do it on one column, multiple columns. But for instance, suppose that we are interested in finding what is the best and worst performing countries specifically within the year 2016. We can sort the values, in this case by economic freedom, which is the main value that we're interested in. And note here that I'm already using the filtered data frame. So that means that we will only in this case look at the values in 2016. So if I do this and I arrange it, it's going to automatically sort based on economic freedom. And it's going to sort in ascending order by default. And that means that if we look at the values, is that in 2016, Venezuela scored the lowest with an economic freedom of 2.88. And in that year, Hong Kong was the highest scoring country with an economic freedom of 8.97. So again, I'm hoping that this shows you how quickly and how easy it is to actually do this. As I just mentioned, the default is to showcase things in ascending order. Obviously, you can change this. So you could also assume a descending value. And that's when by just setting an additional flag to ascending. And it will give you the exact same values, but now in a different order. So that's what we will see in this next column. Good. I hope that with this lab and with this very quick overview, I showed you some of the basic steps in data inspection and especially data cleaning. And I hope that you found this useful. Good. Let me switch back towards the presentation again, because we are slowly getting towards the end of our time. So time always flies in sessions like this. So let me go back towards our PowerPoint, because I hope that this gave you some additional information, and I also have some nice things to give away. So in case you are interested in this and think, well, I'd like to learn more around the big data framework, note that on our website, there's a lot of free resources available. So you can start learning with the free Big Data Guide. You can, if you really would like to make this a career, start to get certified. There's 5 career-based certifications and 4 certificates, which are lighter programs to get started with. We have a podcast in which we talk different data topics with different thought leaders and experts. And we will once again have Big Data Days coming up in May of this year. So it's a 2-day program with sessions all over the world from some of the leading voices in data. So I highly encourage you to sign up for this as well. If you have any questions, please put them into the Q&A or the chat, and I will review them and answer some of them right now. Good, let's get started with the questions that I see coming in the Q&A box. The first one is, I have work experience as a data analyst. Do I need the EBDP to sit for this certification? The answer is yes. So it's a prerequisite. It's an official prerequisite. Reason for that is that in the analyst course, we assume that certain knowledge will be available. So for everyone who's participating there, you don't want to get into discussions anymore around what are standard deviations, what's the difference between supervised and unsupervised machine learning algorithms. So we have set Enterprise Big Data Professional as an official prerequisite. And the reason for that is that we expect people who join the analyst course to have at least a minimum level of knowledge so that you are able to catch up on this quite quickly. So that's the prerequisite. Hope that that answers your question. Then the other question that I see is, how long is the certification valid for? That's a good question as well. There is no expiry date. So as I know that in some other programs you need to recertify every few years, but that's not the case with the big data program. There's plenty of courses to choose from. It's obviously progressive, so the materials are updated very frequently, or at least once a year, to make sure that it follows the latest developments. So if you retake the same exam a few years later, it might have changed slightly, but certificates remain valid forever. So there's no need to recertify. So even if you've taken a big data professional, let's say a few years ago, you can still participate without any problem in any of the follow-up certifications. And then I see another third question popping in, is the exam available only in English? At this moment, there are two languages which we actively support, which is obviously English and Chinese, because that we have a lot of requests from that specific region. So exams at this moment are available in those two languages, so again, English and Chinese. But if you have a large group and you would like to have a translation for which we can make a business case, you can always contact us. We're happy to make translations, but obviously it needs to be worth the volume and the effort of doing that, and especially for maintaining that. So I hope that that answers your question as well. Good. I see a lot of thumbs going up, so I hope that that means it's clear. Thanks so much for the very, very good questions. I hope this was a useful hour spent. Thanks everyone for participating in the session again with us today. I hope you learned something. Please stay posted for our other upcoming sessions. We do this very, very frequently. So if you would like to join other webinars as well, sign up for the mailing list and you'll be hearing from us again very soon. Thanks again for your time, everyone. Good luck on your data analysis projects, and I hope to see you again soon in any of our other upcoming sessions. Thanks, everyone.